Okay, get ready for this. Sometime in the near future, NASA's Artemis II mission is going to send 4 astronauts on an incredible journey around the moon. This is the first crewed flight to lunar space in over 50 years. I mean, it's just this monumental undertaking, a symbol of human ambition and unbelievable precision. It's it's just awe-inspiring stuff. But what on earth
Could a mission on this epic of a scale, this 10-day flight that's literally pushing the boundaries of exploration?
What could that possibly have to do with the day-to-day world of pharmaceutical quality? I know, it sounds like a crazy leap, right? Well, as it turns out, the core principles that get a spacecraft ready for launch are shockingly similar to what it takes to get a life-saving medicine ready for a patient. All right, so let's map out our own little mission here. We're going to start by digging into that Artemis II connection. Then, we'll talk about how readiness starts way before launch, how to anticipate risk instead of just ignoring it, and why it's all about one team, one mission. After that, we'll dive into the power of simulations and wrap it all up with the discipline of success. So what is that core connection? Well, it's actually pretty simple, but it's also really profound. Both of these massive endeavors, they boil down to preparation, readiness, and just exhaustive testing. And why? To make absolutely certain that every single system performs exactly as it's supposed to when human lives are on the line. And that leads us perfectly to our first big idea. Readiness doesn't just happen. Nope, it's built meticulously, piece by piece, over a long, long time. You can't just wait until launch day, or, in our world, batch release day, to start looking for problems. And you can see that parallel right here. On one side, you've got NASA spending years and years testing systems, validating every piece of equipment and training their teams. And on the other side, the world of pharma, where a strong quality system does the exact same thing. See, it's not about catching mistakes at the very end. It's all about proactively building quality into the process from the get-go. So that proactive mindset brings us right to our second key principle. And trust me, this one is a biggie: risk. In these kinds of high-stakes environments, you just can't afford to react to problems. You have to live and breathe a culture of anticipating them. This right here, this is the fundamental shift in mindset. It's not about being afraid of risk. It's about respecting it enough to actually hunt for it, to understand it, and to build rock-solid defenses against it before it ever gets a chance to become a real problem. What's so crucial here is that NASA engineers are constantly asking 3 simple but incredibly powerful questions about every single component. What could fail? What's the impact if it does? And how can we prevent it? Well, that very same investigative mindset is the engine that drives all of our quality and risk assessment tools in pharma. And this is how we actually put that mindset into practice. Tools like FMEA, guidelines like ICHQ-9, processes like change control, these are not just bureaucratic hoops to jump through. No way. They are our instruments for systematically asking, what could go wrong here, and how do we stop it? Okay, next up, let's talk about the people. A mission to the moon is not a solo act, and neither is ensuring drug quality. Success is a team sport, and you absolutely cannot build it in a silo. It just doesn't work. I mean, just think about the incredible team behind Artemis II. You've got the astronauts, the flight directors, the engineers, literally thousands of experts all working in perfect sync. It's the exact same model in pharma. Quality assurance can't do it all alone. It takes seamless collaboration between manufacturing, engineering, regulatory, every single function, all working as one unified team. All right, now for our fourth principle, and I gotta say, this one's a personal favorite: the amazing power of practice. You want to know the best way to guarantee success when it's real? It's to fail over and over and over again in a simulation. And that's really all it is. The entire point of a simulation, whether it's for a rocket launch or a product launch, is to stress the system. You want to find its breaking points, and then you fix them in a safe, controlled environment. So NASA runs countless simulations, right? They're testing every single failure scenario you can possibly imagine. And while we might use different words for it, the pharmaceutical industry does the exact same thing through our own forms of rigorous testing. Just look at our version of simulations. A validation run, that's a simulation of the entire manufacturing process. A mock recall, that's a simulation of a crisis situation. Media fills, that's testing our aseptic processes under the worst possible conditions. Every single one of these is a dress rehearsal, and it's designed to find weaknesses before they could ever impact a patient. So all of this leads to our final and maybe most important principle. The success of Artemis II isn't going to come down to one single heroic moment. It's going to be the result of something way less glamorous, but infinitely more powerful: discipline. See, success is built from these ingredients, day in and day out: meticulous preparation, crystal clear documentation, constant communication, proactive risk mitigation, and seamless teamwork. These are the daily habits that ensure a successful mission, and they're the very same things that create a world-class pharmaceutical quality system. Let's just pause on this one for a second because it perfectly sums up everything we've been talking about. Readiness isn't something you build when the alarm bells are already ringing. It's built by the disciplined, hard work you do every single day when everything is quiet. So at the end of the day, whether you're sending people to the moon or you're sending medicine to a patient, the core responsibility is exactly the same. It's about protecting human lives by making absolutely certain that every single system is ready long before it actually has to be. So I'm going to leave you with this question to think about. In your role, in your daily work, what is the single most critical pre-launch check that you perform? What's that one thing you do to make sure you're truly mission ready?